Hello, everyone. My name is Quentin Ford, and today I will be talking about what is a CBIR framework and how to implement it. CBIR stands for Content-Based Image Retrieval. A CBIR system uses visual features of an image which are described in other low-level features such as colors, textures, and shapes to represent the image in the database. The system uses an example image as an input to search the database and then retrieves several images with similar features to the example image. So basically, what it is, let's say you have a database of similar images or close to it, and you provide an example image. It will search the database for similar images to that example image, and it will bring back the top 20 images that have similar features to the example image that you provided. So some uses of CBIR has texture features, which can be used by using pixels, and what that would do in turn will extract the pixel value in the image. It has color features. CBIR histogram records the color frequency and will use that data to represent the most popular color feature from the example image. And it has shape features. So CBIR can use edge direction information, which will then extract shape features using the CBIR system. So in the CBIR framework, it has 5 steps. The 5 steps are step 1, representing an image using features. Step 2, measuring the distance based on the visual features. Step 3, ranking the images based on the distance between the query image and the target image. Step 4, retrieving the top 20 similar images from the database. Step 5, displaying the top 20 images using a figure window. So, step 1, representing an image using features. As part of the first step of the CBIR framework, we use features, which is a 6-bit color code histogram to represent an image. The 6-bit color code histogram is then extracted from each of the images in the database. The extracted color code histogram is then stored in a matrix of 100 rows and 64 columns. And the 100 rows represents an image, and the 64 columns is the range, because it has a range from 0 to 63, which is why it is 64. Step 2, measuring the distance based on visual features. In the second step, we develop the code which evaluates and measures similarities between two images by using visual feature vectors that are representing the two example images. In this step, in order to measure the distance between two vectors of example images, we use the Euclidean distance formula, and this formula is used to measure the distance between 2 points. Step 3, ranking the image based on the distance between the query image and the target image. So this is the third step in the CBIR framework. This step ranks the images based on the similarity to the example image. It does this by using the distance between the query image and the target image. If the images have less distance between them, then they are similar. But if they have more distance between them, then they are not as similar and not much alike. When it comes to ranking the images with the lowest number in the ranking are similar, and images with the highest number in the ranking are not similar, or not much alike, should I put it that way. Step 4, retrieving the top 20 similar images from the database. In this step, we use the index and sort rows in MATLAB. As you can see, This is how it looks over here. IDX equals sort rows. And by using the sort rows and index, the top 20 images that are similar to the example image that was provided will be chosen. So what this does, this sorts the images out, and the top 20 images that represent or are close to the example image are the images that will be chosen and sorted out. So step 5, which is the last step, um, step 5 is displaying the top 20 images using a figure window. So in this step, we use a subplot in MATLAB to create a graphical user interface, GUI in other words. And in turn, after using the GUI, we can then display the top 20 images in the figure window. So this is some of the code. So as you can see for RGB 26cc fast, this function uses bit shift and polynomial methods to convert RGB images to a 6-bit color code image. So as you see, step 1, it says apply bit shift to get the first 2-bit, which is slow code right here. And step 2, you apply the polynomial method to convert base 4 value to base 10. The next code, which is a function, is get his counts. So this function builds the n-bin histogram count. As you can see, IMG, gray level, image, n-bin, number of bins, range, pixel intensity range is 2 value vectors. In counts, normalize n-bin histogram counts. This is where the bin width is calculated. And this is the lower bound for each bin, and this is the upper bound for each bin as well. And you count the number of pixels belong to the current bin by comparing pixel values to the lower bound and upper bound. And you normalize counts by image size. The next code is create DB. This scans and import for retrieve file information, get data set size, and then you have the create DB here, which DB equals 0 is data size 64, and that number, of course, like we said earlier, represents the amount of columns. You process each image in the data set with this for loop. So as you see, it says for RIDX equals 1 data set size. And in this, it reads an image from the data set and converts RGB image to a 6-bit color code and get normalized histogram counts. Then you would save DB. The next is the get distance, and this function calculates the loosening distance between 2 given points P and Q, where P and Q are 2 vectors of the same size. And this is the code where it all comes together, the CBIR system itself. So this is where you would run it and you would get the top 20 images. As you can see, you have the import path right here, file names, and you have a for loop right here where it says for t idx equals 1 length dv. And then this is the index sort rows, which sorts the 20 images, and it picks the top 20 images that you see right here. And you scan the import folder to retrieve file information. And figure 1, this is where the images, it will display the top 20 images in the figure 1 window in this last for loop. is where the subplot is and where it will be displayed. So if we run it, as you see, pick any image you want from the database. We'll choose this one. And as you see, it displays the top 20 images from the query example image that we chose. Thank you, and that's all.